Okay, alright, check this out. If you live in a cold country, waking up to a thick, dense cloud of fog would be a usual sight. Instead, in this town in the UK, they woke up to a thick, dense cloud of sulfuric acid, a gas cloud, corrosive that could eat their lungs and possibly dissolve their skin. But as always, another amazing story and another incredible event. But as always, it's a bright and beautiful day, and welcome back to another episode of Focus. And thanks for joining once again. So, jumping right in. A chemical company has been fined £2.5 million for releasing corrosive acids into the air in Thurrock, in Essex. A chemical company has been fined £2.5 million for releasing corrosive acids into the air at its site in West Thurrock in Essex. The Health and Safety Executive, or the HSE, said CCTV footage showed a hydrogen chloride gas cloud engulfing the atmosphere within 60 seconds. Nearby schools were closed following the release of the hydrochloric acid from 3 chemical storage tanks in January 2020. 300 liters of the substance were released via a poorly maintained pipe hook. Due to the risk to local residents of exposure to the mitigating or the migrating fumes, emergency responders gave advice to shut windows and doors. The HSC said hydrochloric acid is highly corrosive and hydrogen chloride is a toxic gas. The incident lasted approximately 24 hours. And if you check out the pictures and you can see how thick this cloud was, I would imagine it would have been quite intense for the residents in the area. Anyway, in August 2020, sulfuric acid was released from a crack in a pipe, resulting in 87 cubic meters of sulfuric acid being released into the atmosphere. The authority said the valve that was designed to control leaks in the event of cracks did not operate as intended, leading to the uncontrolled release, increasing the risks to operators and delivery drivers. Sulfuric acid is a highly corrosive gas, highly corrosive substance, and can cause lung damage in high levels if breathed in. An investigation by the Health and Safety Executive and the Environment Agency in January 2020 found that the pipework had not been properly insulated, maintained, and inspected sufficiently, which led to several smaller pipe failures before the more serious loss of containment. It also found that the pipework had not been properly maintained and a protective chemical resistant coating had not been applied to the full height of the containment walls. Another investigation by the HSC into the release of the sulfuric acid in August 2020 identified a lack of inspection and maintenance of the pipework and valves. According to HSC, the leak continued for a further 2 days due to the inability to operate a manual valve to stop the process. No one was harmed so far. The Industrial Company Limited pleaded guilty following the incident in 2020 and was in total fined $2.5 million. The HSE Principal Inspector Maria Strangeward said the uncontrolled release of significant quantities of hazardous substances in these cases were entirely avoidable. An appropriate planned maintenance program should have been in place to ensure that the pipes did not fail and valves operate. The proactive maintenance of the pipework and safety critical valves is extremely important at sites such as these. Industrial Chemicals Limited West Thurrock site is classified as an upper tier site under the Control of Major Accident Regulations, or the 2015. So the businesses and communities are protected and potential major accidents are avoided. Adrian Sherman, the Environment Agency Regulator Officer, said the Environment Agency takes its regulatory responsibilities seriously to protect communities and the environment. We expect businesses to comply with the environmental permits and will take appropriate enforcement action when they fail to do so. In this case, an appropriate inspection and maintenance program could have prevented an environmental and public health risk. But as I like to say, Earth is an amazing place, not just the people, not just the places, but what we have done to it, what we can do to it, and what we have yet still to do to it. And as always, it's amazing how we seem to want to try to destroy it. But as always, that's for the story. If you've got time, stick around for the thoughts and facts. As always, thanks for joining for another episode of Focus. For links to the article, check out the story details or the notes. For more episodes like this, check out future, episodes. If you like it, leave a follow. If not, take care, have a great day, and as always, let no one destroy your zen, let no one destroy your peace. And if you're not having a great day, it's still time to make it happen. Take care. But if you're still around, thanks for joining once again for another Thoughts and Facts section. And as always, our history is pretty vast and we're making it pretty fast. So in the grand scale of it all, I promise to keep it pretty brief. So, as always, let's start with the facts. Sulfuric acid in itself is a chemical formula, or H2SO, is a highly corrosive, strong mineral acid known for its industrial applications and its ability to oxidize, dehydrate, or sulfonate organic compounds. Key characteristics: chemical formula H2SO4, appearance clear, colorless, or brown oily liquid. Properties: highly corrosive to most metals except lead and steel. Strong acid fully ionizes in water to release a high concentration of hydrogen ions. Strong smell, heavy and viscous, miscible in water and alcohol, decomposes and releases toxic gases like sulfur oxides. At high temperatures, the boiling point is 337 degrees, but the melting point is only 10 degrees. The molecular weight is 98 grams per molecule. Other names would be oil of vitriol, sulfuric acid, or hydrogen sulfate. It's used in industrial applications, production of fertilizers, chemical manufacturing, petroleum refining, water treatment, iron and steel production of dyes, drugs, explosives, detergents and plastics, everyday applications, present in car batteries, battery acid, used as a drain cleaner, and in the most unlikely of places, but kind of likely if you have to think about it, in the stratosphere. Sulfuric acid is formed by the oxidation of volcanic sulfur dioxide, and it can nucleate aerosol particles, forming the stratospheric aerosol layer. The hazards: it's highly corrosive to the skin, eyes, and the respiratory system and the digestive tracts. Toxic: it can cause burns, irritation, and in severe cases, systemic effects like circulatory collapse and respiratory failure. First aid: in case of contact, flush affected areas with copious amounts of water. That means rinse it profusely for your life. Handling: should always be handled with caution, even in its diluted form. Now, sulfuric acid as a gas. The gaseous sulfuric acid, the lifetime, meaning how long it exists in the air before condensing onto aerosol particles, varies, but is generally a few minutes. Inhalator, as the scientific term goes, it ranges from 2 to 33 minutes, while in Heidelberg, it was between 0.5 to 8 minutes. Now, this is because of the humidity and the temperature. Many factors depend and affect how long this actually stays persistent in the air. Swiftly moving on. Elaboration: condensation. Gaseous sulfuric acid doesn't stay in the air indefinitely. It reacts with other atmospheric components primarily by condensing onto existing aerosol particles. This process forms new particles or increases the size of existing ones. Factors affecting the lifetime, the rate of condensation, and thus the lifetime depends on factors like concentration of the sulfuric acid in the air, the presence of other chemicals like ammonia, magnesium, or calcium, and the humidity. key principle right here is the humidity. Another study in Haita in Finland found that the lifetime of gaseous sulfuric acid was between 2 and 33 minutes. And as I said before, in Heidelberg, Germany, the lifetime was shorter, between 0.5 to 8 minutes. And this was because of the humidity. Or should we say the cold, the dense. I'll get there in the end. Long-term pollutants. In the stratosphere, some incomplete combustion products of jet fuel can carry lifetimes when reacting with sulfuric acid, with some having half-lives of over 3,000 years. But that's neither here nor there. One more. Sulfuric acid with the chemical formula H2SO4 is a strong acid widely used in various industrial applications. It is known for its high corrosiveness and is a key component in the manufacturing process, like fertilizers, detergents, various chemicals. In the context of its use, it is essential to handle it with care due to its potential health risks. Now, what I wanted to get to about this was the lifetime or the lifespan of this. More or less, it's indefinite. If there is nothing for the sulfuric acid to react with, no impurities, nothing to react with in the container material, no contact with the atmosphere, sulfuric acid is very stable. No internal reactions when there are no impurities. But when this chemical cloud was released, it was released on a nice cold morning, meaning it would have taken a lot longer to disperse. Like they said, 24 hours is when the community was given notice to remain indoors with their windows and doors closed. And it took a further 2 days before they were anywhere near to shutting off the valve itself. In between that time, the amount of hydrochloric gas, that was released in the area, no one knows really how far it spread. The fact that it would have condensed, the dew would have formed, it would have settled on the trees, the leaves, the grass, the buildings, the cars, the homes in the area. And they didn't mention in this article, the fact is that every time it rains, therefore after, it's going to slightly release a little bit of this chemical into the environment more and more. Fact is, it might even raise the temperature. Every time the water interacts with it, it actually causes a slight thermodynamic reaction, but that's neither here nor there. My issue is the amount of people living in the area. I would like to know whether or not the constituents will be seen to if in, let's say, a few weeks, months, or actually from the date this was published, it was 5 years ago, which was 2 years before the conception of this podcast altogether, but that's neither. I digress. The fact is, this has only now come to the courts. The company itself has only now been given a fine, and the 5 years in between that time, I dread to think it wouldn't take this long to prosecute another chemical factory if they caused such a release again in the future. The fact is, in between that time, many of these residents could have developed serious complications from this gas cloud being released. Breathing, respiratory, digestive. It could be persistent in the fact that if there was a large body of water nearby that is, the drinking water of the local residents, it would be in the drinking water and they would continually still be consuming it. So the problem would still be persistent. I'm not going to go into the dreadful state of the rivers and the waterways in the UK itself. From what I've been reading so far, it's not a pretty picture. In many places they advise you not to swim. So, why are we even drinking that water? As always, as I like to say, our history is pretty vast and we're making it pretty fast. And in the grand scale of it all, what's a few minutes of your time? Not that I don't appreciate every single second. As always, thanks for joining for another episode of Focus. And as always, for links to the articles, check out the story notes. For more episodes like this, check out future episodes. And as always, have a great day. Take care.